Hello and welcome to another episode of the How to Create VR tutorial series, where you learn by watching other VR, AR, and MR professionals create the magic. I'm Marcelo Lewin, an immersive content evangelist, creator, producer, and the guy behind howtocreatevr.com. My guest creator today is John Bernhelm, a game industry veteran who fell in love with the Oculus DK2 in 2014 and has been designing VR experiences ever since. I've partnered with John to create a 3-part tutorial series on prototyping for VR. In part 1, we showed you how to sculpt a character in Oculus Medium. In part 2, we showed you how to export the character from Oculus Medium and import it into Maya. In this tutorial, part 3, we'll finish the process by exporting the finalized character from Maya and importing it and using it in Unreal. But before we get started, I want to remind you to register at howtocreatevr.com. It's free, and registration gets you access to video tutorials, practice assets, podcast interviews, ability to favorite, comment, create a watch list, plus much more. It's real quick and easy. Just visit howtocreatevr.com and click on the Register for Free button. All right, John, welcome to the tutorial series once again.
Thanks for having me once again.
I'm glad to have you here. This is part 3. We're closing this series out. It's a great series. And we actually created this great character that we see here in Oculus Medium. Then we exported it into Maya, and you rigged it all up on the last one, right?
Yep, we rigged it, and we did some basic animations. And these are all the kind of basic animations you would need for this to be kind of a working game character.
So now you're going to go ahead and take it and export it out of Maya and bring it into Unreal to basically put it in our game, right?
Yes.
Cool. Real quick, before we do that, we're going to be talking about or working with Unreal today. Really short, why Unreal versus Unity?
Both are incredible pieces of software and amazing game engines, and we're just super lucky to have both of them available, for free, basically, and competing with each other. I've used Unity for many years, but I started using Unreal when I worked with Weaver on the Gnomes and Goblins preview, and I kind of fell in love with its visual scripting system, Blueprint. For some reason, it really clicked with me, and even though I've been coding and scripting with normal text-based systems for years, Blueprint just is a joy for me to use on a day-to-day basis. So I'm making my entire game in Blueprint, basically, and I just think that Unreal is very full-featured when it comes to the art pipeline and with the visual scripting system. So for me, it's just become my engine of choice. I still do projects in Unity from time to time. And then I also really appreciate Unreal's integration for some things, like the way it hooks into Perforce for version control, and that's been very helpful to me. Every studio I've worked in has used some kind of version control system that helps back up your files and then also saves different versions of those files. So if you want to go back to an earlier version or compare them, you can. And Perforce is the software that I prefer to use. So one of the things when I looked at creating my own project, I was like, well, if I wanted to share this project with other collaborators, if I have an artist or a musician, I'd want them to be able to log into the central server and get all my files easily. And I know Perforce front and back, so I was able to set up a Perforce server, and that really worked hand in hand with Unreal. And that works with Unity as well, but the integration's not as smooth and nice. So for me, it's just the ease of use as a designer, being able to touch all these different systems with a visual scripting system called Blueprint, and then also this Perforce integration really put me over the edge. So one of the things, once you start in one of these engines, there's so much stuff to learn. So you just I did a deep dive in Unity for many years and kind of got the ball rolling with Unreal, and I love it ever since.
Very cool. So personal preference, like you said, they're both really good. So we got to get you back here to do a tutorial on Blueprint overview for people so they can check it out, but we'll leave that for some other time. Anyway, I'll let you get started. I know you've got a lot to show. I'll jump in if I have questions.
Sounds good. So this is our file that we made last time in Maya LT 2015. Again, you can do this kind of setup in Blender or any other version of Maya or 3D Studio Max. One of the things that I always do is before we're going to export, and also this is something to kind of do along the way after you have, it's just a kind of a Maya quirk, is to go and delete by type non-deformer history. Sometimes actions you do in Maya will kind of clog up different things with some of these steps that you did along the way, and it sometimes can cause a problem in the export process. So it's just kind of a safe thing to do is to do non-deformer history, delete it. I actually got to select everything first. So I'm going to select all of my geometry and my skeleton. You can tell that they're selected here. I'm going to do edit, delete by type, or delete all by type, non-deformer history. That's just kind of a safety measure that I save after that. So now we definitely have this guy here. He's animated. All the animations are in one file. So that's going to let me just export a single FBX. I'm going to select. And again, this is another safety measure. You probably can just do export, but I'm going to do export selection after I select all of my geometry and my entire skeleton. So you can tell they're all selected. The skeleton is selected. The geometry is selected. I'm going to go to File, Export Selection. And we're going to be doing files of type FBX export. So the options we want to make sure here, I think these are the general options. Triangulate, just make sure the mesh is in triangles, and it's kind of a generic thing that happens. We want animation clicked because we do want to export the animation in this FBX file. The best quality results I've had is baking the animation and doing it every frame. This may be something you don't need to do in some other engines. I know with Unreal, this is giving me the best results. If you don't bake the animations, as you'll see, it isn't exactly how you meant it to be in Maya. So we want to make sure bake animations on the start frame and end frame should be the entire range that we were using. So you can see here it's 1 to 220. So it does this automatically. If you wanted to just export like one part of the animation, like just the idle, then you would change the start and end frame. So it'd be like start frame 1, end frame I believe is 60. But here we're just going to do it all in one big file, and we're going to handle it later on in Unreal. All this other stuff is just kind of default. Yeah, I think this is just the default FBX 2014. I have in my Maya scene, I like having a folder called FBX where I put all my FBX exports. And I'm going to create a new folder here. It's going to be called NPC underscore tutorial. And we're going to do the file name, npc underscore tutorial. And then this is the export. Might get a couple warnings here about the animation curve being changed. That's okay. That's fine. Okay, cool. So we've exported this character. I'm going to go over to Unreal. I already have an NPCs folder. So my game has enemies that are all based on animals from Australia. So you'll see I got koalas and and sharks and stuff. So I went and made a folder called test tutorial, and I can right click in the content browser and do import to this folder is what basically this does. And then now I'm going to find, I've got my Maya project here, the FBX folder, NPC tutorial, and I find the FBX. Click open. There's some options here. This is the import options in Unreal. So there's some stuff that we need to do here. Yes, we want it to be a skeletal mesh. That'll let us animate it. If you don't want it to move, you can just keep it a static mesh by unchecking this. Yes, we want to import the mesh. If you were just importing a file with just animation, you don't need to import the mesh every time. Because this is a new character, we can do a new skeleton. So by having this say none, it'll make a skeleton file for us, which is great. So this is all default. Preserving smoothing groups, great. We don't have any LODs in the mesh, so all this is the default stuff here. It's fine. Yes, we want to import animations. You can change some stuff with animation. You can say that like the exported time, which was from 1 to 220, that's what we want. You can also make it a set range, which says, if you just wanted to import the idle, for instance, you do, frame 1 to 60. And that actually might be what we want to do here. Let's see, what was our idle? Yeah, it looks like it was just 1 to 60. So for this initial import, because it'll make an animation file for us, by doing import animation, we're going to do set range, and then frame import range. It'll say minimum to maximum, so we're going to say 1 to 60. And that should just basically, the animation file it creates on import should be just the idle animation. I know that this character, and most of the stuff I make in Maya is too small for my scale, so I'm going to scale it up. I think I only need to do it 3 here. This will basically uniformly scale up the character 3 times here. And then if you need to, sometimes you'll make something in Maya and it's rotated on a different axis, you would need to change the rotation. The good thing is you can change all these import options after you've imported it. So if you don't get it perfectly right, not a big deal. We're also checking off, I don't have importing materials, importing textures here, because I want to make a new material, and we also don't have textures for this guy. We're going to make a material that is going to be based on the vertex color, and we'll do that in just a minute. Okay, so have that all set up, click import all. It'll create a couple things for us here. It creates the static mesh, the skeletal mesh. So you can see this is our guy. He doesn't have material on him. There's a material slot, says none. But you can tell that all the geometry came in. It looks pretty good. It'll also create an animation file. So this is going to be our idle. So I'm going to go ahead and name this XC tutorial idle. And this should just be our idle animation. And see how it cycles and loops perfectly because we did the right animation settings. So this is in moving, so you can tell that came in okay. Again, if you need to change things, let's say you're like, oh no, this frame range is not good, then we would change that here and then re-import, which we'll do later to make other animations. It'll automatically create a physics asset, which we're not really going to use here, but this is if you wanted to ragdoll the character. It kind of guesses what would be a good way of setting it up. Usually it's not a good setup, but here it's got this weird capsule. This is not a big deal for us, but you can go ahead and hand animate that later. And then the skeleton, the one thing you need to see here is make sure that all of your bones are in the way you want them to be, which looks like they are. I think you can do show. There's a way to show the joints here. I don't remember how to do that. But one of the ways you can test this is you can grab and rotate the joints here. Just make sure, cool, this is exactly what I was looking for. It won't change anything, but you can exit out of that. But so basically, those are things that are automatically created when we import the character. I'm going to do Control-Shift-S, which is save all. And then this little plus sign here shows that I have, this is all hooked into Perforce. So this shows that I've added it to my Perforce repository. So the cool thing here is I've got a little test level for my game. Let's see, I can grab the animation, pull that into the game, and you can see the little guy show up. Notice he's like way too small for my character. This is my game characters over here. Kind of big. So maybe I wanted to universally scale this up bigger than it was. Let me make sure that, I don't pull that one in. So I'm going to go to this was my skeletal mesh. And there should be a scaling setting here somewhere for import. I'm going to go ahead. So import uniform scale. 3 was really small. It should be more like 9. And then I'm going to just click re-import mesh, and boom, it gets bigger. So this is just an easy way to make sure that at the base level, your character is the size that you want it to be. And that looks about right. So we still may need to that scale. Oh, the reason that didn't work before is because the animation also, since it was imported the same scale that we did originally, it was also imported at 3. So I'm going to go ahead and make that 9 as well. And any new animations I bring in with them, I need to set that scale. The other way you can do it is you could just keep it at 1, and then when you bring your character into the Unreal level, you would scale it up. The next thing we're going to do is we're going to create a material so this isn't just loop array. What we did in Medium, if you remember, is we exported it with vertex colors. So that means that every vertex in this model has a color information, and we just want to use that to color it for now. So I'm going to right-click in my content browser to create new material. I'm going to call this mat underscore vertex color. I'm going to double-click it to open up the material editor. Only thing is over here. So the Unreal has a visual material editor. You'd hook textures up to things like the base color. Right now, everything is black because every base color defaults at 0, which is black. What we want to do is hook up the vertex color into the base color. So I'm going to look up vertex color. And so to show you what this would look like, I'm going to apply. You see that it turned the all white. And now I'm going to hit Browse, which will select this material in the content browser. I'm going to go back into, let's open the skeletal mesh. Go back to the content browser. Click on my vertex color material, and then I'm going to click this little arrow, which will apply the selected asset, which is the one we just made here. Okay, so our shader's compiled, and you can see that the colors that we did in Medium have popped up in the sky. They're a little light. I'm not exactly sure why that happens. Somebody who knows more about materials probably could explain that better. But at least we get our base colors in. You can see even the whites of the eyes, which were just something I painted in Medium, pop up. And this is a real easy way to just get a basic material going for this character. So again, that was just taking the vertex color, plugging in the base color. But because the color's a little bit too light here, and I think it'll be washed out, what I'm going to do is add one more node to my material, which is a multiply. And basically, I'm going to multiply this by 0.25, which will darken everything. It's basically taking kind of a dark gray and saying, let's combine that with the color just to darken it. So we're going to hit apply one more time. Okay, and then you can see that the white turned into a bit more of a gray, and that's just going to darken the whole material. So we go back to our MPC. It's going to compile again. There we go. And you can see that it's darker, which I think will look better in the lighting situation in my level. So let's go back to the level, and yep, you can see that the character is in. So this we brought in as a skeletal mesh actor. One way to just to test that it kind of looks cool, the quickest way to just test that it's in there and it's working, so you can set the animation mode on this skeletal mesh actor to use animation asset, which lets you just plug in an animation. We're going to go ahead and just select the idle. Now, when I hit play, guy should just be standing here and idling. I can hit F8 to fly the camera around. And you can see our character is in Unreal, is animating, and that's a great start. The next thing I want to do is make an animation blueprint for this character where I can hook up a look at so his eyes will follow the camera around. So animation blueprints are connected to the skeleton. So the way you can select the skeleton asset in the content browser, right-click, and there's one of these things called Create. And so there's a bunch of different things you can create here. And what we want to do is create anim blueprint. So I'm going to call this animbp underscore NPC underscore tutorial. And this animation blueprint's already hooked up to this skeleton and already selects a skeletal mesh, so it's ready to go for him. And the way that Unreal works is your character will be a blueprint, which is kind of will control a lot of its stuff, but the animation itself is controlled by animation blueprint, and those two things need to talk to each other sometimes, so that your character blueprint will be the thing that'll like say, I know what my health is, and I know I just got hit because my collision just got stomped on. But the animation blueprint is what says like, oh, I know that my health is at 0 and I'm dying, so play the death animation. Or I've been told to play an attack animation, so this is what that looks like. Don't have enough time to go into exactly what all this stuff does here today, but we'll just do some real basic stuff. So what I wanted to show you is that we set up this character's eyes so that the eyes can rotate, and I want to get the eyes to look at me. So at the end of this tutorial, we'll have an idling, a static or skeletal mesh object that has eyes that can look at the camera. So the way we're going to do that is using the animation graph and the animation blueprint. So basically, the animation graph right now just says we're just going to be playing, it actually says nothing. So you see how he's not even animating here? We want to add that idle animation that we had here, which I called idle. So if I type in idle, you'll get this play NPC to idle. If I hook this up and hit compile, then you'll see, cool, he's just going to play this idle animation forever. What we want to do is after it processes the idle animation, this is basically like all the stuff that's going to be happening that's contributing to the final pose that you see on the screen. So the cool thing about Unreal in this system is that we can do things like add IK or manipulate some joints, and then it'll be added on top of this animation that we already have. So what I'm going to do here is change the space from local to component. This changes the way that some of the things in the animation blueprint work. Some of them need it to be in component space. You can tell it's a component space because it's got this little blue character instead of the white character here. And basically what we're going to do is we're going to take our animation, turn it from local to component. We're going to do some look-ats. Now, look-at is a skeletal control node that takes a bone and then tries to rotate it so it's rotated towards something. We're actually doing 2 of these because we're going to be doing it one for each eye. And then notice that when it comes out, it's still in a little blue character here. And if I connect to the result, it'll go ahead and automatically say, let's turn it from component space back to local space. So this is the basic. What we're going to be doing is we're going to be playing our idle animation, and then we're going to, on top of that idle animation, we're going to be doing a look at for the left eye and a look at for the right eye.
Real quick question. Why did you have to turn it from local to component, and obviously then it had to go back to component?
Yeah, it's basically this node is something that's built into Unreal's animation system, and it requires this. Like, I'm not exactly sure. Yeah,
it requires it be in component, whatever that is.
in component space. So there's different, when you're talking about, the 3D rotation or location, there are a number of different, you have to figure out like what space that rotation or location is in. Like basically like what is the starting point in terms of its reference. So world space means that 000 is at the center of the world, whereas you also would have a local space as character where 000 is maybe the center of the character. And so sometimes you'll do things that are, if you are in world space and you say move this bone to 000, it's going to move that character's bone to the middle of the world regardless of where the character is. Usually you don't want to do that. Usually you want to keep it in the space of the
character.
Yeah. So that's what the local space is. Component space is even broke down
more
even
granular.
Even further. Yeah. And so I'm not exactly sure why under the hood this requires it, but that's basically the way to think about it. And the good thing about Unreal is like it'll do a lot of this automatically. So let's say I typed in, I wanted to do a look at node just like that. And you forgot to do that. You try to drag over here. It'll automatically say convert pose length structure to component space. So it'll go ahead and add that for you. So it does a lot of smart stuff just to do that. And so I would, I didn't need to set those up myself. I could have just connected it and it would have just done it.
Yeah.
So it's good at hinting at that stuff. But what we're going to do here is set up these lookats. Save first. Okay, so our axis is going to be, we're going to start it with y equals 1. I think that's the way it's supposed to go here. Let's check the bones first. So we have this IR and IL. We're going to go ahead and change these. So you'll see here it says look at bone is the IR, the other one's IL. And you can tell this did something because it made our left eye disappear. And that's okay because right now it is pointing at, it's pointing at basically 0, because we haven't told it where to point at. So that's okay. We'll get in there, figure it out. What we're going to do is, it says target, look at target. So you can either have a bone look at another bone within the same hierarchy, or what we want to do is have it look at a location, which is going to be where our headset is. So I'm going to click on this, look at pen. And we're just going to work on the right eye right now, just to speed it up, and then we're going to copy over and then change the left eye to add to that. So now we have a pin that says look at location, and I want to go ahead and I'm going to make this, if I right click on the pin, I can say promote to variable. So this is going to be, I'm going to call this variable look at target. So basically our eye is going to be looking at wherever the location this represents. Now this is another thing about the space. So we actually don't want our look at to be in local space. We want it to be in world space, I believe, because, is that right? Let's see. We need to look up access. I think we want this to be, because our target is going to be in world space. It's going to be wherever the headset is. And then our target is going to be the same for both the left and right eye. Go ahead and just copy this. So set this to left eye. Our look at target, we can hook that into both the left and right eye. So this is basically going to represent where the eyes are going to look. Compile. Now they're both, because this look at target, default for this variable is 100.
But that variable is going to be set up or populated by the headset, basically, the coordinates.
Yeah.
Okay.
So, and you can see, let's go ahead and we're going to set this default target to be in front of him. So we see our y-axis is out here. So let's say we want it to be 200 in y and probably 200 in z. And you can already see that it already moved the eyes. So the cool thing is if you click on this node, you'll get a visualization of what's happening. So you see that little blue, there's like a blue line here with a little plus mark. That plus mark is our look at target. So this is where he's trying to look right now. So what I'm trying to do here is I'm going to set this default to be straight ahead so we can just get a base so we know like, okay, this is what straight ahead looks like. So it's a little low, so we're going to bump up Z to 400. That's probably a little high. 300. As you can see, he's kind of looking straight ahead here. Let's make the Y a little further out so that it is more representing what we're going to try to see. Yeah. Okay, cool. So now we have our eyes, and you can tell that he's looking each one of these look at nodes. So I click on these look ats, and you can tell that the bone is pointing towards this thing, which is cool. That's what we want. Now, one of the neat things you can do in the animation blueprint editor is, so we set the default of this look at target value. Actually, it's not even, we didn't even do it right. Okay, so this is where we want to set the default. Again, this is going to be overridden by the headset. This is just to establish a baseline. And then down here, this is called the animation preview editor. You can actually change this in real time and see how it works. So if I change the X value here, it'll move our target from left to right, and we should be able to see the eyes follow this. So yeah, so if I make X really big set to 500, you see the eyes go to the left, or his left, my right. If I change it to negative, you'll see them go this way. So you get the sense of how this is working. That's great. So that's working. And then if we change the Z, so it goes up and down, you should see the eyes go up and down. Now, the problem is that we didn't set up our eyes to be perfect, so they're going to clip in here. What we can do to minimize that is we can set a constraint. So each of these look-ats, there's actually there's a clamp. Okay, so there's a look-at clamp. So if you click show pin here, this gives us a little pin for a look-at clamp. And what the look-at clamp is it basically says, hey, don't let us rotate all the way around to see this. If this is off or 0, then these eyes can go 180 degrees, which means that if I move the eyes to be behind him, they go behind, they pull behind his head, and that's really freaky. We don't want that. We want them just to kind of move around a little bit. So what I'm going to do is I'm going to right-click on look-at clamp, make that a variable just so it's easy to hook to both of these. Hook it to both of these. I'm going to make that variable's name look at clamp file, and then this is default to 0. I'm going to set look at clamp, the default value to, I believe, 20 is probably what we want. Okay, so now I can go back into my preview editor and play around with look at target and see what's the worst case scenario of how does it look. So here, this is basically the range that it has, which is not perfect. That one eye is kind of sunk into it, but it's fine to get what we want, which is just some basic look-ats going here. Same thing if I do Z up and down. So this is kind of like the extents that I can look at. It can look. Cool. So we know that basically whatever value I feed into look at target here, this character's gonna look. So the cool thing is you could then do something in its character blueprint to say hey, if there's another enemy near me, I want to look at that enemy. Or here's if you're doing a story experience and you want a character to look at an object, you can just place that object's location into here and it'll look at it. The other thing that you can do is look up something with this alpha. Alpha basically is how much of this is actually affecting the bone. If this is 0, let's go ahead and move the look at target so you can see this. Okay, so he's looking up. He's looking down and to the side. So if I take the left eye and I set this alpha to 0, it'll turn off that eye. So here you can see the right eye is moving, the left eye is not. So alpha controls how much that this actually kicks in. If it's at half, then it'll still do some movement, but it'll do less movement than it would have otherwise. So a lot of times what you do is if we wanted the character's AI to control turning this on and off, we'd hook something in the alpha. I'm not going to do that today, but it's a powerful tool. So sometimes you can do things like if the player looks at, so Astrobot has these flowers that when you look at them, they look at you and they do a little animation dance. So we could do a thing where we detect the player looking at the character and then have them turn this alpha on or ramp into it, lerp into it so it goes gradually into 1.0, and then that character will look like it wasn't looking at you and then start looking at you. And that's a pretty cool effect, especially in VR. But all we're going to do is go to event graph, and the event graph has this event update animation. So this is basically when it ticks, it's going to run anything here. And what we want to do is I'm going to click on look at target, hold down Alt, and say pull out look at target, it'll automatically set it. You can also just grab look at target, bring it out, and then click set look at target. So basically we want to set look at target to the location of the camera every frame. And the way we do that is right click and say, I'm just type in get camera. This is another thing I love about Unreal Blueprint is they have really strong context sensitive stuff. So if you have a general idea what you're looking for, it'll generally point you the way you want to go. So this said get player camera manager. We know that our player is 0. That's basically if you're doing a single player game, your player is going to be index 0, so that's fine. And then on this return value, type in get location. One of the nodes will be get camera location. So this is an easy way to get a camera location at any time. You're going to get a little error if there isn't a camera, and that usually is the first frame of the game. So one of the things you tend to do is you'll drag off this and just type in is valid. This is just a good check to make sure that the camera manager even exists. So basically what this is saying is if there's a camera manager, then do set the location of the look at target to the location of the camera. Now you're not going to see any weird change here because we have no camera, but what should happen is if we go into here, our character, we had him, so this character, I'm just going to duplicate him so I can show you the difference. So the character on the left is the one we originally placed. My other character, so I can select this guy. So this is the guy we originally placed here, and he was set to just play this animation as his animation mode. The new one we made, we're going to set it to use animation blueprint. And the animation blueprint he's going to use is, it doesn't automatically show you which ones are valid for that character. It should do that, but it doesn't. So I'm going to click on my NNBP NPC tutorial, and then click on the arrow, and that'll hook him into that. You notice his eyes move. So he's definitely doing something different than this one. So what should happen is this character should just idle. This one will be playing the animation blueprint, which says idle, and then change the eyes to follow the character. So this is in my game. You can see the eyes on the one character kind of following me, looking at me up, looking at me down, and that's just going to give him a little bit of life. I'd like to show you what that looks like in VR real quick. In VR, the cool thing about this is that it's hooked to my camera, and so I can, as I move around, I see that those eyes are following me. And this is a pretty big character, and he's kind of far away. My scale for the world's pretty big, so I'm not getting like a ton of movement just with my head moving. But you can see it is definitely, I'm going to kind of like move around the room here a little bit.
Yeah, you can see his left eye moving.
His eyes are following me.
Yeah.
Okay, I'm going to get out of VR now. Okay, so we're back from VR. We were able to test this character out in play in editor mode as well as in VR preview. And as you can see, we brought a character in that we sculpted completely in Oculus Medium. We were able to rig it and animate it in Maya very quickly and then bring it into Unreal as a character that we can now see it moving and even updating its animation to follow us with his eyes.
John, this was awesome, man. It was just so great to be able to see. Well, first of all, thank you for doing all of this. This was just, I think people are really going to get a good idea, especially people that are newbies to this, are going to get a good idea from what it takes to go literally from the idea portion of it, sculpting it, creating it in Medium, and even seeing how the layer names follow through into Maya, then into Unreal, right? Because they all remain the same, basically.
Yep.
Yeah. So thank you for showing us this entire process. It's been truly eye-opening.
You're welcome. And where I would take it from here is now I'd start building, AI features using the other animations that we made and things like that. So that maybe we'll do a future tutorial about that stuff.
Hey, that sounds like a great tutorial. Thank you so much, John. If people want to get a hold of you, what should they do?
They can tweet me at Bernhelm, Bernhelm. And you can check out my game, Roobound, which is the project we're in right now, at roobound.com. That's ROOBOUND.com.
Excellent. Well, thanks again, John, and to the rest of you, I'm glad you were here with us. Just a quick reminder, if you want more video tutorials just like this one, assets to practice with, podcast interviews, plus much more, please make sure you register for free at howtocreatevr.com. Also, if you are ever in the Southern California area, we have a monthly meetup with lots of great VR, AR, and MR presentations. You can join or RSVP for our next meetup at howtocreatevr.com/meetup. So until the next episode, I'm Marcelo Lewin. Cheers, everyone. I love that, man. Oh, the punching, man. When you're done with this game, you gotta let me play with it.
Oh, well, yeah. I'll let you play with it way before then.
That's awesome.
I need some testers.
Dude, I'll be your tester.